Good morning, friends. Welcome to Water Resources Engineering class. In today's lecture, we discuss on some problems. The following are the rates of rainfall. That means rates of rainfall means rainfall intensity for successive 20-minute period of a 150-minute storm. 2.5, 2.5, 10, 7, 1.25, 1.25, 5. Suppose if I draw a hydrograph like this, 20 minutes if I take it, 0, this is 20 minutes, 40 minutes, 60 minutes, 80 minutes, 100 minutes, 120 minutes, 140 minutes if I take it. Suppose what is the initial thing, for example, here it is time, here it is rainfall intensity. So initial thing is how much, if I take it, this is 2, 4, 6, 8, 10 maximum. So initial one is 2.5, right? Accepted. Next thing is also 2.5, accepted. Next one is 10. Rainfall. Next one is 7.5. Next one is how much? 1.25. Next one is how much? 1.25. Next one is how much? 5. So this is what we call it as, all the whatever we have drawn is nothing but rainfall hydrograph. Then what he has mentioned, the value of phi index is 3.2 centimeters per hour. So somewhere here the phi index he has given. So this is phi index. Right? Find the net runoff. What is the net runoff? Net runoff means this. What is this net runoff? And also find out the value net runoff, total rainfall and W index. 3 values he asked. So this is the question. You understood? First thing is rainfall hydrograph he has given, because it is intensity. Phi index also he has given. 20 minute basically he has given the during each storm actually. So now what are the questions asked me? Net runoff in centimeters, that is number 1. This is number 1. And total rainfall number 2. W index number 3. First total rainfall I will take it. How to calculate total rainfall? Always rainfall is equal to, rainfall means in terms of what he has asking, so much of total. So rainfall in terms of depth units, rainfall in centimeters is equal to, right, intensity into time. Intensity into time. That's all. During first 20 minutes, what is the rainfall? During first 20 minutes, 2.5 centimeters per hour. 2.5 into duration is how much? 20 minutes. Per hour I want. That means 60. 20 by 60. 2.5 into 20 by 60. Next one is again 2.5 into 20 by 60. Next one is 10 into 20 by 60. 7.5 into 20 by 60. 1.5, 5 into 20 by 60. So if I put sigma into intensity into time, if I put it, but please be careful when you are writing the time, units should be per hour, you should remember. Here in minutes he has given, I converted into hours like this. So total is 10 centimeters. So your second answer is over. 10 centimeters rainfall total. So this total figure corresponds to 10 centimeters of rainfall. What is our next question? What is net runoff? Net runoff. So what is, he has given phi index 3.2 centimeters per hour. So what is the equation for phi index? Immediately you should write PE minus R by TE. What is PE? Effective rainfall. R is runoff. T is effective time duration. Now what is PE we will think of. PE means actually effective. How effective? It should be such that during that duration, the rainfall intensity is more than the average infiltration rate. Here the average infiltration rate is nothing but phi index. So during when? So for example, if you take it first duration, it is less. So this is not counted. Second duration, still it is less. It is not counted. Third duration, it is more. So that's why it is counted. Fourth, counted. Fifth, no. Sixth, no. Seventh, counted. So only we counted 3. So that's why I put 10 plus 7.5 plus 5. So all these are which units actually? Centimeters per hour. Into I converted into centimeters. That means into duration is, each duration is how much? 20 and minutes. 20 by 60 if I put it hours. So 7.5 centimeters. Why only 3 considered? That you should know. While calculating even phi index calculation also, please understand this is our first logic. Right? Here accept the 3 values of rainfall intensity, others are less than phi index, hence they are not considered for while calculating effective rainfall. Right? Then again next question, what is TE? TE means during the first thing, no. Second thing, no. How many durations are there? 1, 2, 3. Only 3 durations. So that's why I put 3. Only during these 3 durations only the rainfall is basically excess. Into 20 by 60 to convert into hours. So finally phi index is 3.2. 7.5 is just now we got it, minus or divided by 1 is equal to runoff is equal to 4.3 centimeters. Next, let us go W index. I already told in the W index there is nothing we omit actually. So W index, when P means P indicates total rainfall. That is the difference between phi index and W index. R is total runoff and initial loss. All we should. TF is total duration. Now you see TF is what? Total duration is how much? 140 minutes by 60. This is the total. So total rainfall already you found out first initially. 10 minus 4.3. Initial losses are 0 because they have not given. So I assume it 0. Divided by 140 by 60, it is 2.42 centimeters per hour. So phi index is 3.2, this is 2.42 centimeters per hour. Another problem, right? Before going into the problem, see the graph which I have given. Actual how the infiltration rate varies is by Harton's curve. And what is this part actually? This is what I have drawn. It indicates the rainfall hyetograph. The rainfall hyetograph. And rainfall hyetograph I superimposed Harton's curve. This is the accurate method. If you superimpose it, the rest one, all this is runoff. And all this is infiltration. But our problem is calculation of this is not that simple. So that's why we simplified the process. Instead of all this, we put a straight line. And this we mentioned, below this is infiltration, above this is runoff. So that is how the infiltration indices have come. We have simplified the Horton's curve thing, which is exponentially decreasing. We make it an average value rather than initial high, next like that. Rather than taking it, we make an average value. That is what phi index and W index are. A 3-hour storm on a small drainage basin produced rainfall intensities 3.5 centimeters, 4.2 and 2.9 centimeters per hour. 3 rainfall intensities in success. If the surface runoff due to the storm is 3 centimeters, what is the value of phi index? This is what we have asked actually. So what is PE? For example, if I take it, the phi index, PE I want to calculate. PE I want to calculate means effective rainfall only I have to calculate. So if I draw it actually 3.5 centimeters, 4.2 centimeters and 2.9 centimeters. Strictly drawing, if the surface runoff due to the storm, the total surface runoff volume is 3 centimeters only. So that's why effective rainfall is equal to all 3 put together into basically the time hours, it's only in hours, 3 hour 1. Then I have put it effective rainfall time duration is 3 hours. Then we found out what is phi index. Then what is W index? So all 3 into this 10.6. Effective duration, the total duration is 3 hours only. Surface runoff is 3. Initial losses are 0. So here both are going to be the same only. Again a 6-hour storm. A 6-hour storm with hourly intensities produced. Phi index is 7, 18, 25, 12, 10 and 3 mm per hour. Produced a runoff of 33 mm. So then phi index. So now phi index is not known. So I have taken all here actually. So total 75 mm minus this divided by the total. So that's how I calculated this. TE is 6 hours, surface runoff is this. The rainfall of 3 successive 6-hour period is this. Now only rainfall is given. If the initial loss is this, then find out basically the phi index and the W index. Phi index is equal to PE minus R divided by T. PE is effective rainfall, R is surface runoff, T is the total duration rainfall intensity is greater than phi index. Suppose if I take it, previous problems if you take it, there I got rainfall intensities, whereas here you see it, it is only rainfall values. Right? So if I take the rainfall values, now runoff also I got it. So now during all these 3 times, the runoff is there or not? During the first period, there is no runoff at all. So that's why please understand what is the difference between the previous. In the previous problem, these are all intensities. Because of that intensity versus centimeters I am not considering. Only intensities versus intensities or centimeters versus centimeters. So here 1.3 centimeters doesn't contribute rainfall, doesn't contribute anything to runoff because runoff is basically 3 centimeters. So this is 4.6, 3.1. So therefore 4.6 plus 3.1 is 7.7 centimeters. Runoff is this and duration is only the first 1 hour. It doesn't contribute anything. Only 2 hours it is contributing. So that 2 hours we have put it and got the answer. Whereas when I take the W index, total I will take it. So total is, that means 1.3 plus 4.6 plus 3.1, 9 centimeters. And this is runoff and total duration is 3 into 6. That's how I calculated this. So phi index accounts for infiltration loss, interception loss and depression storage, evaporation loss, all the above. You all know the phi index represents only infiltration loss. Which of the following has the highest infiltration capacity? Forest land, gauged pasture, concrete pavement, rock outcrop. Naturally, forest land, basically its infiltration capacity is very, very high. One more problem we have taken. The total observed runoff volume during a 6-hour storm with a uniform velocity of 1.5 centimeter per hour is this. Now I am doing it in terms of volumes. If the area of the basin is 300 km square, find the average infiltration rate. This is the question. Because till now, intensities we have taken, depth we have taken. Now I am taking volumes into it. Total observed runoff volume because of a 6-hour storm is with a uniform velocity as given is this much. Area of the basin catchment is 300 km square. Average infiltration rate of the basin, find out. Total rainfall. What is the rainfall intensity? 1.5 centimeter per hour. How much is the storm duration? 6 hours. So 6 into 1.5, 9 centimeters. Accepted? Right. What is the volume of runoff? He has given already 21.6 into 10 to the power of 6 meter cube. What is the area of the basin? 300 km square. So 300 into 10 to the power of 6 meters square. Kilometer is equal to 1000 meters. Depth of runoff. Volume by area. Volume is this. Area is this. So what is this depth of runoff? So depth of runoff I found. Then what is total infiltration? Already total rainfall is 9 centimeters. What is the total runoff is 7.2 centimeters. What happens to the rest actually? This 9 minus 7.2 naturally has to be infiltration. That's what we have done. What is the total average rate of average infiltration means infiltration rate. So 1.8 centimeters is in which hours? How many hours? 6 hours. So what is mm per hour? This is the rate. So this completes to me. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.